All right. Can we see it? Great. I can't see it, but everybody else can see it, so we'll run with it. So anyway, what is a traditional repeater? It consists of an antenna, duplexers, which is just a set of cavity filters, bandpass filters, and band reject filters. There's a receiver, a controller, and a transmitter. And you can see on the little block diagram there um, pretty much how it all ties together. So on the 9.2 repeater, you've got a receiver tied to the repeater controller, which is tied to a transmitter. Those are both glued together with a duplexer, and it goes out to the antenna. Oops, 2 slides. What is voting? Voting is just a method of selecting the best signal. It's really interesting because fundamentally what it is picking the least noisy signal. That's all there is to it. There's multiple receivers scattered across the county, and the noise comparator samples multiple times per second. So you may hear it switch voter sites intra word, between syllables even. And this whole device sits upstream of the repeater controller. So why build it? It improves receiver performance. It allows us to transmit with a really high power, like 100 plus watts, from the main site, and then you can run a handheld pretty well anywhere in the county and get in full quieting. It adds redundancy, so if one receiver starts having issues, we can fail over to a bunch of others, and we can mitigate jamming. If there's some new kid with a Baofeng that decides to jam our stuff, we can just isolate that voter in that geographic area and notch out those issues. So why not build it? It requires a bunch of sites. We're fortunate here to have a bunch of sites to work with, but many clubs aren't. It's difficult to maintain, and it requires a lot of expensive test equipment. Just to generate the right signals to actually calibrate it, it's quite tricky. There's a high initial cost, and the hardware is quite difficult to find. The actual box that we use for all this is actually end of life and has been for probably 10 years. So when I see them on eBay, I snatch them up, and that's part of my greater problem of collecting radios and handhelds and stuff. And I have 4 of these voter comparators that I'll likely ever only need 1 more. And similar hardware is required for best results. All of the remote sites should be identical or very close to identical. In our case, we've settled on Motorola hardware because they do their filtering just about the same across the board. High-level signal chain. So each of the remote sites listens on 146.3.2. That's our repeater input. It goes through the voting comparator, which is then summed up. There's the repeater controller, and then through the transmitter. Right? And that comparator is the one that's picking the least worst signal. So on the 146.9.2 repeater, though, the last slide was just generalized. This is more specific to our application. The main site is connected directly to the voting comparator, or the voter, and the remote sites actually are crossband repeaters. And we've got additional receivers up on the main site that receive those remote signals and then pipe it to the voting comparator. Does that more or less make sense? Just everything as a whole and how it flows. Awesome. So this is the main site. The top box is the repeater control, or the repeater itself, and it's also the main site receiver. The WX250, that is our weather receiver. So on Wednesdays, you'll hear the automated test. That's the WX250 chiming in twice a day. The next box down, the SCOM, that's our repeater controller. The next one is the voting comparator. And then the last one is the voter interface box. And that's a bunch of glue logic, a bunch of 7400 series glue logic that Bob and I put together to really hold this system together. That's the duct tape in the rack. Then at the very bottom are a bunch of CDM radios, and those are our receivers for all the remote sites. So inside the comparator, you've got a receiver, an amplifier. There's a high-pass filter, an amplifier, and then a low-pass filter. And that effectively measures the noise, right? So the output on this line right here, hopefully y'all can see my cursor, that's a DC value that corresponds to how noisy the signal is. So the microprocessor, the pick chip down here, just says, hey, this one's the least noisy. And then it tells the audio matrix which one to pick, and that's how the audio gets pushed out. Geographically, this is how everything is spaced out. You can see the Roston's a little by itself, but Roston also has an antenna at 1,750 feet. It's what, about 1,400 feet higher than the main site. Some would call that a little crazy for us to run a receiver higher than the transmitter, but it actually works fairly well and doesn't tend to invite any issues. It very well covers that northwest quadrant of the county. The rest of the county is covered by those sites, in down to the southeast and Justin. And man, it works really well. There's not a spot in the county that you'll have a hard time getting in with a handheld. Yeah, Justin's offline. Yep, because the water tank got removed without them saying they would do so. Yeah, Henry, what happened? You were out there and it just. Yeah, he said he went to see how the voter or why the voter didn't work, and he found out. Yep, and water tank was missing. There's a big hole in the ground, right? Yeah, left the antennas for us. Yep. That was nice of them. But yep, in some cultures that would be regarded as an ass move. But I it's okay. They've offered other space, so we'll take them up on that. So what does our hardware typically consist of? The LDG RVS8. That's the rare beast that I'm hoarding when I find them on eBay. Sounds like Mike is too. It was a QST project in the mid-90s. They actually published the schematics and the source code, and then LDG went out and actually built it. The VHF radios are CDM 750s. The transmit radios, the remote transmitters, are VRM 650s. That's a vehicle radio modem. It's modified though, and it works just fine for what we need it to do. Yeah. Yep. If you're familiar with Motorola stuff, it's an MCS 2000 with a lot of police cars back in the day. You might still see them in the city of Louisville, trash trucks. But by and large, they're pretty well end of life and whatnot. And then at the main site, we've got the CDM 1550s. That was in the picture earlier. Let's see here. So this is what one of the remote sites looks like. In fact, the one on the right is the Justin site. That was the Justin site. So I'm told that cabinet housed the original 9.2 repeater. Is that correct, Gerald? Oh, the original 8.5 repeater, back before they invented the 9.2. Yeah. Before sliced bread? 1975? Okay. Yeah. Wow. So anyway, that cabinet may or may not make the trip to the next water tower, but we'll see. But you can see on the left, the radio on the top is the transmitter with a fan very carefully zip tied to the back. And then the receiver underneath that, and then the power supply on the bottom. We do have remote control over these bits. This is a snippet from our web control panel, and you can see we've got a bunch of net nodes on the left, and then the middle column and the right column are our voter control bits. And we've actually got a way to watch which voter is picked in real time and to quantify the signal coming into that voter in real time. It's a bar graph that updates, and it's pretty cool. It just waves at you, and the columns change color depending on which one's picked. So it's really easy for us to see that, say, Mike is jamming the grapevine voter, and then to mute his ass and disable that particular voter. Ah, yes, it looks exactly like this. You can see that Justin is selected here. Yep. UT Dallas is locked out. That's what the gray bar means. And this is noise level. So the lower the bar, the cleaner the signal it is coming in. But this is just a really fun and easy way for us to monitor everything and keep an eye on how our system's doing. So difficulties in Denton, the RVS8 drifts. Sometimes you'll hear the voter make a bad decision. Sometimes it'll go from a full quieting signal to a not so full quieting signal. And maybe that's for good reason, or maybe it's not. And likely it is because the pots, the potentiometers inside the voter box, drifted with temperature. Okay, these are not 10-turn pots. These are like a 3/4 turn. And what I'm talking about is like a volume knob, right? And the problem with something that's not 10 turns is that just the slightest little touch will knock it out, right? And with a 10-turn pot, it takes 10 full turns for you to go the full range of that pot. But on these ones, it's easy to knock it out of cal. Power supply issues. We had a 60 hertz hum on the Justin voter. That was that's fixed. Yeah. Yep. Yep. Not a problem anymore. It's been pretty quiet. It was a ground issue. Yep. It's difficulty maintaining a bunch of hardware. The Yagi on Ralston often gets hit by ice. And currently, the Yagi on the Roston voter is hanging by the coax under the platform. It's inconvenient, but you'd be amazed it actually still comes into Denton pretty well. That's what good line of sight will do for you. The transmitters tend to fail. The VRM 650s are a lot better than anything we've had before, but back when we had the Max Tracks, the PA, the power amplifier would get so hot that the transistors would slide off the PCB. It would reflow the solder. Yeah, it would desolder itself and it would destroy itself because typically it would short out on the way down. One of the tabs would go between the drain and the ground, and drain is what you energize on these. And yep, direct short. Oh, my bad. Yep. Anyway, what can you blame the voters for? The good, county-wide HT coverage, the bad. Sometimes you get some changes in the noise floor. It sounds like loose coax when it's switching voters. You might hear like a quick kerchunk, a squelch drop or something like that. That's when it's switching voters. It can happen between syllables. And then we get the intermittent 60 hertz hum from the, well, never mind. Normally we'd get it. Yep. But anyway, I say it's still probably your radio though. Anyway, the future of the voting system, we're going to be upgrading hardware. Bob and I have been talking forever about building our own voting comparator. We've got schematics that we've talked about. We've got all these great ideas. We just haven't built anything yet. We talk a good game. We just actually need to capture the schematic, lay it out, and build one. And do what? Oh yeah, with Bob's free time in retirement. Yeah, as president from DCARA. Yeah, yep, plenty of time to build us a voter. We've talked about going to an entirely digital signal chain with Raspberry Pis and RTL SDRs. Again, that's all talk, but it would be really slick if we could do that. I've really wanted to do that particular method because I'd like to give you, the DCARA members, the opportunity to put up a voter at your house. So if you live in a hole or something like that, still want a home run or help out, you just set up this little node and set it in your closet, and that provides HT coverage around your neighborhood, right? So that would be awesome. Effectively microcells of voting. But again, that's all hypothetical and just where we'd like to go, but don't really have the clock cycles to get there. Any questions? I know that was a really quick talk. Yeah, Tom. Kind of. Actually, some hardware is donated tonight, and that will be going into some of these systems. Yeah. Yes. Yeah. And yeah, should that rare beast die, the voting comparator, I have 3 more sitting in my guest bedroom because I have an eBay problem. Hi, my name's Andrew, and I have a problem. Yeah. Anyway, any other questions? Oh, Bob. Bob is asking, in lieu of the 1550s, do we want to change them over? And honestly, if it's not broke, I don't want to fix it. I trust the VRM 650s. I haven't had one blow up yet. They're still relatively new. The oldest one in service is about 3 years, so there's still plenty of opportunity. But the 1550s will be all of our next round of upgrades. So the Salina site, Keeley still needs one. Froston, UTD is still a pair of Max Tracks. So the Max Tracks were mid 80s era Motorola vintage, great radios of their time, but they've served their useful purpose. Yes. The Max Track was about the only thing that looked the same after I dropped it off the tower on Roston. It was a crater, but it was identifiable at least. Any other questions? Anybody on Zoom? All right, nothing heard. Well, thanks for tolerating my little speed run there, and the technical difficulties leading into it.